In this section, we'll be coding an example of synchronized methods. We'll be creating a simple example of a fast food restaurant. We will create new class fast food restaurant where clients can buy burgers. We'll be maintaining a counter when a client buys a burger to track the number of burgers sold. We will also print the name of the client who entered the store last. We will implement this example without synchronization first, and then we'll implement with synchronized methods. So let's create a class, new Java class, and the class name is fast food restaurant. So we will define two class level variables, which are the last client name and number of burgers sold. So private string last client name and private integer number of burgers sold. Now we'll implement a method buy burger. So public void buy burger and string client name and this dot class name last client name is equal to client name and number of burgers sold plus plus and printing out the name of the client who bought the burger. So client name plus bought a burger. Now let's implement a long running process. So it is just sleeping, and so here we'll be just sleeping the thread for 2 seconds. And let's add the try catch. And let's call this a long running process when you buy the burger, and this process is basically making the burger. And the reason why we have defined this outside is we'll be implementing this example with synchronized block, synchronized method. So we have a use for this, and you will see that use very soon. Let's implement getters and setters. So right click, generate getters and setters. And let's create public static void main. Inside public static void main, we'll be measuring the time it takes to run this program. So long start time is equal to system dot current time milliseconds. And now create an instance of fast food restaurant. Fast food restaurant is equal to new and fast food restaurant. Now start 4 threads thread T1 is equal to new thread. So we're starting 4 threads because there are 4 buyers who buy the burgers and they came in parallel. So we'll be providing the name of the clients who will be buying the burger in this 5 burger. Let's say it was Mike, and then thread 2 is equal to new thread. And here we have another client, Syed, and thread 3, which is another client. And let's say it's Gene. And thread T4 fast food restaurant.buy burger. Let's say it was Amy. So we have 4 clients who walked into the store to buy the burger. Now let's start those threads. T1 dot start, T2 dot start, T3 dot start, and T4 dot start. And then wait for all those 4 threads to finish, or to have their order ready. And let's add the exception handling here. Add exception to method signature. That will take care of all the errors. And now let's print out total number of burger sold plus fast food restaurant dot number of burgers sold. Get number of burger sold. The last name of client is plus fast food restaurant dot get last client name. And last, we are printing out how long it took to execute this program. Execution time plus system dot current time millisecond minus start time plus in milliseconds. Now let's run this program. So you can see that Mike bought a burger, Syed bought a burger, Amy bought a burger, Jean bought a burger, total number of burgers sold is 4, the last name of client is Jean, and total execution time is around 2 seconds. Now let's run this program again. So here you see Mike bought a burger, Amy bought a burger, Jean bought a burger, and Syed bought a burger, but the total number of burgers sold is 3. So, but we sold 4 burgers. So why the total number of burgers sold is 3 is because there are 4 threads, and those 4 threads are increasing the counter by burger, and this by burger is increasing the counter of number of burgers sold. So there may be a race condition created by those threads, and those threads have the wrong copy, or they have the value of those variables which was not reflecting the current state of number of burgers sold. So that's why we are saying the total number of burgers sold is 3 instead of 4. So let's see how we can fix this problem. So what we'll do is that we'll just copy this program, copy, and then paste it, and then rename this example to fast food restaurant synchronized method. And here in this one, what we will do is we will just make this method synchronized. It has to be public synchronized void. And now let's run this program. So you can see the total number of burgers sold is 4, but take a look at the execution time. It took 8 seconds to run this program, whereas the previous program which we ran took 2 seconds to run the program. Now let's run this program again. So total number of burgers sold is correct, but it is taking 8 seconds, and the reason why it is taking 8 seconds is when the first thread comes in, it runs a long running process, and all other threads have to wait for it, and when it gets the complete execution done by the first thread, when the second thread gets in, run this whole statements, run these 4 statements, and then once it executes the 4 statement, then the thread 3 comes in and then run it. And you can see that because there are 4 threads and every thread is sleeping 2 seconds, that's why the execution time is around 8 seconds. So when we were running it without synchronized method, it was taking 2 seconds, but this synchronized method, it is taking 4 seconds. So in the next section, we'll look into how we can optimize this program so that instead of 8 seconds, it will take lesser amount of time to run this program and without this synchronized method.